position.
Yes.
So this is actually the single most exciting part of the process, because this is when spider crane transforms from mobile spider crane into stationary spider crane. And to do so, it's going to get very spider-like.
The spider crane deploys 4 adjustable legs.
We're going to the max.
Max, every time.
Ready for deployment.
Each leg extends out over 7 feet.
And this is actually happening. We're making the spider crane.
Unlike tower cranes, which balance their loads using counterweights in the rear, the spider crane relies on its low center of gravity. Standing just 5 feet tall and weighing half as much as one counterweight, it can teeter on the edge and lift a 2,000-pound glass panel without toppling over.
Here she comes.
Okay.
The full spider transformation.
With all 4 legs keeping it balanced, crews swing the boom outside of the tower.
Okay. Extend the boom, which I'm going to extend and retract. Oh my God, I thought of something else. Look at the color choices of all the instructions. Oh, are they black and red and blue, like the outfit of a certain superhero named
Peter Parker.
Peter Parker. He's absolutely right. This is not a crab crane, as the cartoon may have led us to believe falsely. It's obviously a spider crane. Okay, I'm deploying the spider boom right now. And what's also totally amazing, I attached a tiny camera to the edge of the boom. Check it out. Spidey cam out over the abyss.
To reduce the wind's impact, the spider boom extends just 3 feet beyond the building's threshold.
Okay, she's coming down. We're coming down.
The hook is then lowered to a glass team 1 floor below, where they operate the spider crane by remote control.
Push, 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 push. Oh, she's going. She's going. Oh, here comes spider crane.
Despite hugging the building,
Oh boy.
75-mile-an-hour gusts can still catch the 14-foot panels.
Hang on tight. Trolley's coming out. Now, as you look at them fuss with this, you can imagine how much more challenging this would be if this piece of glass was suspended by a 200-foot-long cable. Making these minute adjustments would be almost impossible, given how much it would move in the wind.
Here we go.
Here we go.
The precision controls of the spider crane allow the crew to maneuver with less than 1/4 of an inch of clearance.
Beautiful.
All while under the force of a Category 1 hurricane.
All right.
All right.
This team's record, 52 panels in 1 day.
The glass is in place, installed in 5 minutes.
5 minutes, yes. Spider crane is so important for us.
Nothing more I can say. Glass gets done, Baku is windy, none of it stops us. It's 2 words.
Spider crane.
I love it.
Up next, covering a curving interior the size of 7 football fields.
So you need a material you can bend.
With over 19,000 panels installed by hand.
Robert, it's heavy. It's heavy. Robert, it's heavy.
Azerbaijan is a predominantly Muslim nation, once home to nearly 2,000 mosques. But after 70 years of Soviet occupation, the country is left with just 18 remaining today. Baku's new cultural center is a contemporary reimagination of this country's ancient Islamic tradition.
So in a lot of ways, this building is a kind of modern reinterpretation of a historical element that was in the Azeri culture.
Yes. When you look at this region's traditional architecture, you see the ornamentation and frescoes on the ceiling and the walls and the floors. Everything flows into each other.
So if you look pre-Soviet at the history of the Azeri culture, you look at their carpets, their ceilings, their walls, there's a sense of continuousness, seamlessness. The pattern's going to go on forever.
Yeah, it symbolizes infinity and eternity of the universe.
Architects designed an undulating space frame roof from almost 60 miles of steel. Clad in over 16,000 white panels, it creates a continuous pattern that also created continuous problems for builders.
The roof of the cultural center is so complicated that quite literally nobody knows how to build it. Now to figure it out, they've created a kind of on-site mock-up facility, which they affectionately call the graveyard. The reason is, each and every one of these attempts has failed. Color wasn't right, geometry wasn't tight enough, the gap didn't line up. So far, of all of these attempts, only one guy has pulled it off.
Each and every panel is different. Each and every panel has a curve in either direction. And to put them all together with the exact joints which is specified, that is where the challenge is.
So making a project of this size must be an enormous fabrication effort.
It's a nightmare. But I think we have solved it.
It took 2.5 years of experimentation to figure out how to create one smooth exterior surface. On the interior, crews faced the same complex geometry, but on two separate surfaces. Both walls and ceilings curve and blend together, creating a facade that flows like fabric, with no hard edges or straight lines.
Here at the Cultural Center, there is a direct relationship between the curvature of the roof and the curvature of the ceiling. So if the roof bends over like this, well, that same space is created on the inside of the museum. The question then becomes, how do you sheetrock that? So, Hannes, when you think about sheetrocking your house, put up the studs, hang up the sheetrock, screw it in. And it goes really fast. Sheetrock, screw, paint it, skim it, done.
Yeah.
But this, in many respects, which you think is the easiest job, is one of the most complicated jobs in the entire project.
That was my first idea. I said, no, this will never be built because it looks like science fiction. Never ever.
Right? It curves like this. In the library, it curves like that.
This. Yeah.
Over in the concert hall, it curves like this. All throughout the building, you have different twists and curves and bends that you have to follow.
Yeah. So you need a material you can bend.
So, Hannes, this is it. This is the material right here.
Yeah, this is the board.
The entire interior curved space, floor, wall, ceiling, up, down, left, and right is all made out
All
of this.
Yeah, we can show you how to bend it. All right, let's take it up.
So it's,
You go over there.
Yeah,
You
so-
turn it to the left, and I turn it right.
so what we're gonna do is we're gonna bend it in two directions.
In two directions. I come to you, and we do it like that.
Look at that. Normal sheetrock doesn't want to do this.
Engineers created a new material called flexboard.
Should I break it?
Yeah, let's see what's inside this thing.
While it does eventually break, a tight weave of fiberglass strands allows it to bend 3 times more than traditional sheetrock.
Okay.
Okay.
And my cherry picker. I have my super flexible sheetrock.
Absolutely. We
Have my
got
friend
Robert here on board.
Robert needs to come with us. All right. Let's make floors become walls, Hannes. Let's go.
Crews have just begun, covering the nearly 500,000 square feet of wall and ceiling, an area the size of 7 football fields,
All right.
with every piece of flexboard installed by hand.
So now we are up in the curvature when the wall curves up to become the ceiling. And Hannes, what I find so amazing is I look at the sheetrock, it's like almost a collage of different pieces.
Yeah.
A rectangle, a trapezoid, a triangle, odd cut parallelograms. Each one's going to be a different shape.
Yes, it is. The more the curve, the smaller you have to cut the board.
While this curve requires a custom cut for every piece,
Okay, here we go.
the top bends at a relatively gentle 20-degree slope,
This is going to be awkward.
allowing the crew to use a whole 8-foot-long, 4-foot-wide panel.
Okay, now we need your help. You have to go down,
Follow the line. Yep.
go down.
Follow the line. I got you.
Follow the what? Go
Follow
down.
the line.
All right, and
Go, go, go.
All right. So Robert starts screwing over there.
All right, Robert. It's heavy.
It's heavy? Come on, he's not heavy. He's not
Look
that
at the
heavy.
size of you, Hannes. You're like a German mountain goat.
No, I'm Bavarian, by the way.
You're a Bavarian mountain
I'm
goat.
Bavarian, yes.
Yes. Yeah.
Okay.
It's held up.
It's fixed. Just have to hold it.
I'll pop a couple of those puppies in there.
Once in position, crews fix each piece to aluminum brackets hung from the space frame.
Nice.
Flexboard sacrifices strength for flexibility. At half the thickness of typical sheetrock, it requires a second layer to make it more durable.
This does give you a sense of absolutely how brutal it's going to be to cover each and every inch of this place with this sheetrock. I mean, come on, this is not going to be easy.
See?
All right.
When this team finishes in 3 months, they will have covered the space with over 19,000 pieces of flexboard. Laid end to end, they would stretch over 28 miles.
So, Hannes, when it's all said and done, it's going to feel like one continuous white curving shape that wraps the inside of the entire building.
It's a unique building in a unique city, definitely.
I promise you, this will be an experience. This will be a space unlike any you've ever seen before.
Up next, atop the country's tallest tower, climbing to the very tip of the flame.
Be careful. Yes, absolutely. Okay, the ladder rung broke. It's not like I'm climbing on the edge of a building. That'd be really dangerous.
But first, what was the very first application of a space frame? The answer after the break. Here is your trivia answer. Alexander Graham Bell first utilized a space frame in 1900, attempting to make a lighter flying machine. The liberation of Azerbaijan from the Soviet Union was not a peaceful process. In 1990, a year before the fall of the Soviet Union, hundreds of thousands of Azeris got together to protest for their independence.
Between the Azerbaijani militants who'd taken control of the city.
That night, Soviet tanks rolled into the city and opened fire.
On the streets of Baku, Moscow's patience snapped.
They killed 137 civilians. In commemoration of that event, they tore down a Soviet monument and built this. It's called Martyrs Lane, where they recognize each and every person killed that day. And at the very end of this lane is a flame that burns eternally in their remembrance. Thousands of Azeris visit this flame every year, honoring those who fought for Azerbaijan's freedom. Now, 20 years later, the country is celebrating their independence with a different kind of symbol, by building the tallest towers in the entire region.
The first thing you notice is that you can see these towers from everywhere in the city.
Oh, yes, that's for sure. I mean, I can still remember that moment when I first saw that rendering, and I said, you know, I want to go build that. I think it's going to be that special.
And you're also doing it in a place that was just recently a part of the Soviet Union. There wasn't a tradition for building this kind of architecture here in Baku.
We're trying to bring to Baku an iconic building. It's going to put Baku on the map.
While the lower 39 stories of the building are made from concrete, the top needs to emulate the movement of a flickering flame. So architects designed a 100-foot tall crown made from steel. But where the two materials intersect presents a unique challenge for the builders.
The challenge is, how do you connect a steel structure to a concrete base? Because as you might know, you can't weld steel to solid concrete. It just won't stick. So the solution is to insert into the very tops of the final 11 columns a massive steel plate to help make that connection. And this right here is that plate. So this lets us change the structure. This is how we go from a concrete building
to steel.
To a steel building.
Yes.
And so all of this steel I'm looking at, this whole stake essentially, gets inserted in. When we're all done, we're left with a flat steel plate.
Yes, we put the anchorage inside the column and pour in concrete and lock the anchorage.
On the 39th floor of the third tower, the final 11 steel anchors, weighing 1,200 pounds apiece, are embedded into the top of each concrete column, giving workers a steel base to support the over 500-ton flick.
So basically the building from here down, total concrete building.
Concrete.
And then from this line up, pure steel.
Pure steel.
And today we're going to put this where we're putting it up there?
Yes.
Jeez, that's high.
To install each anchor, iron workers have to climb onto temporary scaffolding perched 550 feet off the ground.
So just to be clear, we're going up on the edge. No handrail, no nothing. Let's get safe. Let's get safe. Okay.
Are you ready?
What's going on here? You get dressed in the morning, you have help too? And like, your shoes tied too? Let me check. Let me check your shoes.
Check, check.
Who cut your goatee? You have help in the morning doing this too? This is amazing. You're like a magician from the Renaissance. I love it.
Every morning I shave it and like 3 musketeers.
3 musketeers.
Every morning.
Your 3 musketeers. What were their names? It was D'Artagnan?
Athos, Porthos, Aramis, and D'Artagnan.
I'm so not surprised you knew that instantly.
Well,
All right, I'll be Athos, you be Porthos. Let's go find D'Artagnan up there.
yes, let's go.
Okay. Everything's cool.
Each anchor is over 4 feet tall.
Look out.